Hi everyone, in this video we will learn about number sequences and patterns, finding specific terms and spatial sequences.
Number sequences and patterns. In primary school, we have learned how to recognize patterns in some number sequences and how to find the next few terms or missing terms of a number sequence. For example, 5, 10, 15, 20, 25. Here, we get the numbers in the pattern by skip counting by 5. Now look at the table here. We will sheet all the multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, and so on. So what is the seventh multiple of 5? 1, 2, 3, 4, 5, 6, 7. So the answer is equal to 35. What is a sequence? A sequence is a set of things, usually numbers, that are in order. Each number in the sequence is called a term, or sometimes element or member. The first term is 2, the second term is 5, the third term is 8, the fourth term is 11, the fifth term is 14. 3 dots means goes on forever or infinite. So the set of numbers 2, 5, 8, 11, 14, and so on forms the number sequence. The numbers in the number sequence are known as the terms of the sequence. The first, second, third, fourth, and fifth terms are 2, 5, 8, 11, and 14 respectively. The numbers are governed by a specific rule. Start with 2, then add 3 to each term to get the next term. Infinite or finite. When the sequence goes on forever, it is called an infinite sequence. Otherwise, it is a finite sequence. For example, 1, 2, 3, 4 is a very simple sequence, and it is an infinite sequence. 20, 25, 30, 35, and so on is also an infinite sequence. 1, 3, 5, 7 is the sequence of the first 4 odd numbers and is a finite sequence. 4, 3, 2, 1 is 4 to 1 backwards. 1, 2, 4, 8, 16, 32, and so on is an infinite sequence where every term doubles. A, B, C, D, E is the sequence of the first 5 letters alphabetically. J, A, and E is the sequence of letters in the name Jane. 0, 1, 0, 1, 0, 1, and so on is a sequence of alternating zeros and ones. They are in order. It is an alternating order. In order. When we say the terms are in order, we are free to define what order that is. They could go forwards, backwards, or they could alternate, or any types of order we want. Like a set. What does it mean by a set? A set is a collection. It is just things grouped together with a certain property in common. 0, 1, 0, 1, 0, 1, and so on the sequence of alternating zeros and ones. The set is just 0, 1. Notation. Sequences also use the same notation as sets. List each element 3, 5, 7, separated by a comma, and then put curly brackets around the whole thing. These curly brackets are sometimes called set brackets or braces. A rule. A sequence usually has a rule, which is a way to find the value of each term. Example. The sequence 3, 5, 7, 9 starts at 3 and jumps 2 every time. Positive even numbers 2, 4, 6, 8, 10, 12, 14. The rule is start with 2, then add 2 to each term to get the next term. Positive odd numbers 1, 3, 5, 7, 9. So the next two terms are 11 and 13. So start with 1, then add 2 to each term to get the next term. Multiples of 3. 3, 6, 9, 12, 15, 18, 21. Start with 3, then add 3 to each term to get the next term. Powers of 3. 1, 3, 9, 27, 81, 243, 729. Start with 1, then multiply each term by 3 to get the next term. Finding rule that generates sequences. For each of the following sequences, state the rule of the sequence and write down the next two terms. Question A. 42, 39, 36, 33, 30. And after that, 27 and 24. So we know here, start with 42, then subtract 3 from each term to get the next term. The next two terms are 30 minus 3 is 27. 27 minus 3 is equal to 24. Question B. Negative 22, negative 18, negative 14, negative 10, negative 6. The next two terms are negative 2 and 2. So the rule is start with negative 22, then add 4 to each term to get the next term. Let's check. Negative 22 plus 4. The absolute value of negative 22 is 22. The absolute value of positive 4 is 4. Which one is greater, 22 or 4? 22 is bigger. So we copy its sign, negative. The difference between 22 and 4 is 18. So negative 22 plus 4 is equal to negative 18. Next is 256, 128, 64, 32, 16. So the next two terms are 8 and 4. Why? Because the rule is start with 256, then divide each term by 2 to get the next term. Next, B, negative 1, 1, negative 1, 1, negative 1. 1, negative 1. So the rule is start with negative 1, then multiply each term by negative 1 to get the next term. So let's check. Negative 1 times negative 1 is equal to positive 1. We just write it as 1. As a formula, 3, 5, 7, 9, and so on. So now here, we can see the sequence goes up 2 every time. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. So we can guess that the rule is something like 2 times n. So here, we will test the rule. The first term is 3. The second term is 5. The third term is 7. Let's test it out. 2n. So 2 times 1 is equal to 2. If n is 2, so 2 times 2 is equal to 4. When n is 3, so 2 times 3 is equal to 6. That's nearly worked. But it is too low by 1 every time. So let's try changing it to 2n plus 1. So 2n plus 1. 2 plus 1 is equal to 3. 2n plus 1. 2 times 2 plus 1, 4 plus 1 is equal to 5. 2n plus 1. So 2 times 3 plus 1. 6 plus 1 is equal to 7. So now we can calculate, for example, the 100th term. Is equal to 2n plus 1. 2 times 100 plus 1 is equal to 201. Notation. To make it easier to use rules, we often use this special style. Cn is equal to n term. Cn is the term, while n is the term number. So, a rule for 3, 5, 7, 9, and so on can be written as an equation like this. Cn is equal to 2n plus 1. So the general term of the sequence is 2n plus 1. And to calculate the 10th term, we can write it 2 times 10 plus 1. 20 plus 1 is equal to 21. Finding specific term. For each of the following sequences, state the 100th term T100. The multiples of 3, 6, 9, 12, 15. So we know here, this is start with 3, then add 3 to each term to get the next term. 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15. So the Cn is equal to 3n. So to get the 100th term is 3 times 100 is equal to 300. Perfect squares. 1, 4, 9, 16, 25, and so on. So we know here the first term is 1, the second term is 4, the third term is 9, the fourth term is 16, the fifth term is 25. So you can see here they are squares. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So the general term is Cn is equal to n squared. So to get 100 terms is 100 squared is equal to 10,000. Perfect cube. The first term is 1, the second term is 8, the third term is 27, the fourth term is 64, the fifth term is 125, and so on. So we know here they are cubes. 1 cube is 1, 2 cubes is 8, 3 cubes is 27, 4 cubes is 64, 5 cubes is 125. So the general term of the sequence is n cubed. To get 100 terms is 100 cubed is equal to 1 million. Given that the n terms Cn of a sequence is Cn is equal to 5n minus 3. Find A, the third term, and B, the difference between the third term and the fifth term of the sequence. We will find the third term first. Cn is equal to 5n minus 3. We substitute n with 3. So 5 times 3 minus 3. 15 minus 3 is equal to 12. And then the fifth term is equal to 5 times 5 minus 3. 25 minus 3 is equal to 22. So the difference between the third and the fifth term is 22 minus 12 is equal to 10. Spatial sequences. Numbers can have interesting patterns. Now let's look at some spatial sequences and their rules. An arithmetic sequence is made by adding the same value each time on to infinity. the difference between one term and the next is a constant. For example, 1, 4, 7, 10, 13, 16, and so on. This sequence has a difference of 3 between each number. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 3 is 16. So the common difference is blank 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 and 3n. The first term is 1. How to get the zero term? We will count backwards. 1 minus 3 is equal to negative 2. So the zero term is negative 2. So the general term of this sequence, Cn, is equal to 3n minus 2. So we join the common difference and the zero term. 25, 23, 21, 19, 17, 15, and so on. The common difference is negative 2. 25 minus 2 is 23, 23 minus 2 is 21, 21 minus 2 is 19, 19 minus 2 is 17, 17 minus 2 is 15. So the common difference is blank 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 and negative 2n. Then we will find T0. The first term is 25. How about the zero term? We will count backwards. The opposite operation of minus is plus. So 25 plus 2 is equal to 27. To get the general term, we join the common difference with the zero term. So Cn is equal to negative 2n plus 27. Or you can write it as Cn is equal to 27 minus 2n. Here we have odd numbers 1, 3, 5, 7, 9, 11, and so on. So the general term for the odd numbers is Tn is equal to 2n minus 1. Let's check. The first term is 1, the second term is 3, the third term is 5, the fourth term is 7. We will find the fourth term. T4 is equal to 2 times 4 minus 1. 8 minus 1 is equal to 7. Even numbers 2, 4, 6, 8, 10, 12, and so on. So the general term for the even numbers is Tn is equal to 2n. Let's check. We will find the fourth term. The fourth term is 8. So to get T4 is equal to 2n. 2 times 4 is equal to 8. Geometric sequences. In a geometric sequence, each term is found by multiplying the previous term by a constant. So here we have 2, 4, 8, 16, 32, 64, 128, 256, and so on. So this sequence has a factor of 2 between each term. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and so on. So what we multiply by each time is called the common ratio. So the rule is Tn is equal to 2 to the power of n. For example, the fourth term is 16. T4 is equal to 2 to the power of 4. 2 times 2 times 2 times 2 is equal to 16. Here we have 3, 9, 27, 81, 243, and so on. So this sequence has a factor of 3 between each number. The pattern is continued by multiplying by 3 each time. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and so on. So, to get the general rule is the n is equal to 3 to the power of n. For example, we will find the fourth term. T4 is equal to 3 to the power of 4. So 3 times 3 times 3 times 3 is equal to 81. Triangular number sequence is generated from a pattern of dots which form a triangle. The first term is 1. The second term, we'll draw a triangle. So now there are 3 dots. The third term, the triangle is getting wider. And don't forget to draw the triangle. So now there are 6 dots. The fourth term, now there are 10 dots. So by adding another row of dots and counting all the dots, we can find the next number of the sequence. So the first term is 1, the second term is 3, the third term is 6, the fourth term is 10, then 15, 21, 28, 36, 45, and so on. The general term of this sequence is Tn is equal to n, open bracket, n plus 1 close bracket, out of 2. For example, we will find the fifth term. The fifth term, the answer is 15. The fifth term is equal to 5, open bracket, 5 plus 1 divided by 2. So 5 times 6 is 30 divided by 2 is equal to 15. Now let's compare with another triangular numbers. If there is one triangle, there are 3 lines. If there are 2 triangles, there are 5 lines. If there are 3 triangles, there are 7 lines. So 3, 5, 7, 9, 11. 9 and 11 is the next 2 terms, the fourth term and the fifth term. Next here, we know the common difference is 2. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. The common difference is 2. And then after that, the first term is 3. Now we will find the zero term. If count forward, plus 2. If count backward, minus 2. 3 minus 2 is equal to 1. So the general term of this sequence is Tn is equal to 2n plus 1. For example, we will find the fifth term. The answer is 11. T 5 is equal to 2 times 5 plus 1 is equal to 11. Square numbers. Numbers which can be arranged in a square shape. For example, 1, 4, 9, 16, 25, 36, 49, 64, 81, and so on. So the next number is made by squaring where it is in the pattern. So for example, the fourth term is 16. So 4 squared is equal to 16. So the general rule for square numbers is Cn is equal to n squared. Cube numbers. Here is a cube. 1 times 1 times 1 is equal to 1. 2 cubed. 2 times 2 times 2 is equal to 8. 3 cubed. 3 times 3 times 3 is equal to 27. 4 cubed is 64. 5 cubed, 125. 216, 343, 512, 729, and so on. So the general rule for the cube numbers is Cn is equal to n cubed. For example, we will find the fifth term. N cubed, 5 cubed, is equal to 125. Here is the first term, second term, third term, fourth term, fifth term is 125. Rectangular numbers are numbers that can be arranged in a rectangular patterns of dots. The first 4 figures of the sequence are as shown. The first term is 6 dots. The second term is 10. The third term is 14. The fourth term is 18. So we can see over here the common difference is 4. The first term is 6. The zero term is 6 minus 4 is equal to 2. So the general term of this sequence is Cn is equal to 4n plus 2. For example, we will find the fourth term. The answer is 18. C4 is equal to 4 times 4 plus 2. 16 plus 2 is equal to 18. Now let's compare with another rectangular numbers. 2 squares make a rectangle. So the first term is 2. The second term is 6. The third term is 12. The fourth term is 20. The fifth term is 30. So the general term of this sequence is Cn is equal to n, open bracket, n plus 1 close bracket. For example, we will find the fifth term. The answer is 30. C5 is equal to 5, open bracket, 5 plus 1. So 5 times 6 is equal to 30. Fibonacci sequence. The Fibonacci sequence is found by adding the two numbers before it together. So the next number is found by adding the two numbers before it together. Here we have 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. and so on. So we can draw this triangle. Start with 1. Then we will draw the triangle. And then the triangle is getting bigger. 1 plus 1 is 2. The triangle is bigger. 1 plus 2 is 3. 2 plus 1 is 3. One plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. The triangle is getting bigger. So now here, the Fibonacci sequence said that the next number is found by adding the two numbers before it. So here is 1. 1 plus 0 is 1. And then 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 plus 1 is 5. 1 plus 4 plus 3 is 8. 1 plus 5 plus 6 plus 1 is 13, and so on. So the general rule for the Fibonacci sequence is Cn is equal to Cn minus 1 plus Cn minus 2. For example, for this sequence, we will find C6. To get C6 is C5 plus C4. The fifth term is 1, 2, 3, 4, 5. The fifth term is 3, while the fourth term is 2. 3 plus 2 is equal to 5. Find the sixth term. 3, 5, 8, 13, 21. We know that this is the Fibonacci sequence. How do you know? 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21, and so on. So, to get the sixth term is C6 is equal to D5 plus D4. First, second, third, fourth. This is the fifth term, and here is the fourth term. So 21 plus 13 is equal to 34. Pascal triangle is the triangular array of numbers that begins with 1 on the top and with 1s running down the two sides of a triangle. Each new number lies between two numbers and below them, and its value is the sum of the two numbers above it. To build the triangle, start with 1 at the top, then continue placing numbers below it in a triangular pattern. So here is the first row is 1. The second row is here, 1 and 1 on the left and right side. Here is the third term. One plus 1 is 2. Here is the fourth row. 1 plus 2 is 3. 2 plus 1 is 3. The fifth row. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Here's the sixth row. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Here is the Pascal Triangle. The first term is 1. The second term, 1 plus 1 is 2. The third term, 1 plus 2 plus 1 is equal to 4. The fourth term, 1 plus 3 plus 3 plus 1 is equal to 8. The fifth term, 1 plus 4 plus 6 plus 4 plus 1 is equal to 16. So we get 1, 2, 4, 8, 16, 32, 64, and so on. Remember, the 3 dots means goes forever. So, the general terms of this sequence is Cn is equal to 2 to the power of n minus 1. So, for example, we will find the T5. The fifth term is 1, 2, 3, 4, 5. The fifth term is equal to 6. So, Tn is equal to 2 to the power of n minus 1. So, 2 to the power of 5 minus 1. 5 minus 1 is equal to 4. 2 the fourth power is 2 times 2 times 2 times 2 is equal to 16. Many rules. Mathematics is so powerful. We can find more than one rule that works for any sequence. So it is best to say a rule rather than the rule, unless we know it is the right rule. What's the next number in the sequence? 1, 2, 4, 7. The first solution is add 1, then add 2, add 3, add 4, and so on. So, the general rule is Tn is equal to n, open bracket, n minus 1, close bracket, out of 2 plus 1. So, to get the fifth term is T5 is equal to 5, open bracket, 5 minus 1 divided by 2 plus 1. 5 times 4 is 20, out of 2 is 10. 10 plus 1 is equal to 11. The second solution. After 1 and 2, add the two previous numbers. Then plus 1. 1 plus 2 is 3, plus 1 is 4. 2 plus 4 is 6, plus 1 is 7. So, Tn is equal to T n minus 1 plus T n minus 2 plus 1. So, to get the fifth term is equal to T4 plus T3 plus 1. The fourth term is 7. The third term is 4 plus 1 is equal to 12. The third solution is after 1, 2, and 4, add the 3 previous numbers. 1 plus 2 plus 4 is 7. So Tn is equal to Tn minus 1 plus Tn minus 2 plus Tn minus 3. So to get the fifth term, T5 is equal to T4 plus T3 plus T2. The fourth term is 7. The third term is 4. The second term is 2. Seven plus 4 plus 2 is equal to 13. So, we have 3 perfectly reasonable solutions, and they create totally different sequences. Which is right? They are all right. General term of more complicated number sequences. Consider the sequence 2, 5, 8, 11, 14, and so on. Notice that the difference between consecutive terms are all equal to a constant. The common difference of this sequence is 3. 2 plus 3 is equal to 5. 5 plus 3 is equal to 8. 8 plus 3 is equal to 11. 11 plus 3 is equal to 14. So this is called a linear sequence because the formula for the general term is a linear expression. So by looking at the pattern, we know that the common difference is 3n. And after that, we will find the zero term. The first term is 2. How about the zero term? We will count backward. So 2 minus 3. 2 minus 3. The absolute value of positive 2 is 2. The absolute value of negative 3 is 3. Which one is greater? 3 is greater. So that we copy its sign. The answer is negative. And then the difference between 2 and 3 is 1. So 2 minus 3 is equal to negative 1. And then we will join the common difference and the zero term. Tn is equal to 3n minus 1. Let's check. For example, we will find the fifth term. The answer is 14. So T5 is equal to 3 times 5 minus 1. 3 times 5 is 15. 15 minus 1 is equal to 14. The second method, transforming to another more familiar sequence. 2, 5, 8, 11, 14. The common difference is 3. Since the common difference is 3, we can transform the original sequence to a new sequence which consists of terms that are multiples of 3. The first term must be 3, so that we know that the general term is given by 3n immediately. The first term is 2, the second term is 5, the third term is 8, the fourth term is 11, the fifth term is 14, and so on. Multiples of 3 are 3, 6, 9, 12, 15, and so on. 2 plus 1 is 3, 5 plus 1 is 6, 8 plus 1 is 9, 11 plus 1 is 12, 14 plus 1 is 15. Since we add 1 to each term of the original sequence to obtain the corresponding term in the new sequence, we will have to subtract 1 from 3n. as we are moving backward to get 3n minus 1. Therefore, the general term of the original sequence is Cn is equal to 3n minus 1. For example, we will find the fourth term. C4 is equal to 3 times 4 minus 1 is equal to 11. The third method, connecting the sequence to its graph or by observation. The first term is 2, the second term is 5, the third term is 8, the fourth term is 11, the fifth term is 14, and so on. So let's say this is x, is the input. Here is y, the output. Then we will draw the graph. Here is the x-axis. Here is the y-axis. 1, 2. Remember? X, Y. 1, 2, 2, 5, 3, 8, 4, 11, 5, 14. Then join all the points. Draw a straight line and extend until you find the y-intercept. Y-intercept means the value of y when x is 0. Y is equal to mx plus c. We will find the gradient. The gradient is how far up out of how far down. We will choose these points. How far up is 1, 2, 3. How far along is 1. The slopes upward, so the gradient is positive. 3 divided by 1 is equal to 3. Y is equal to mx plus c. The gradient is 3. So 3x, c is the y-intercept. The y-intercept is negative 1. 3x plus negative 1. Y is equal to 3x minus 1. So, the general term of the original sequence is Cn is equal to 3n minus 1. The members in the family of chemical compounds are made up of carbon atoms and hydrogen atoms. Question A. The number of carbon atoms and hydrogen atoms of the first 4 members in the family are given in the table. Copy and complete the table. Here's the member number. 1, 2, 3, 4, 5, 6. Here's the triple dots, means goes forever. So the general term of the sequence is equal to n. Number of carbon atoms. 1, 2, 3, 4, 5, 6. So the general term of the sequence is n. And then here, number of hydrogen atoms. 4, 6, 8, 10, 12, 14. For that, we will find the general terms. 4, 6, 8, 10. The first term is 4, the second term is 6, the third term is 8, the fourth term is 10. So now, the common difference is equal to 2. Why? 4 plus 2 is 6. 6 plus 2 is equal to 8. 8 plus 2 is equal to 10. So we know the common difference is equal to blank 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 n. 2n. After that, we will find the 0 term. The first term is 4. So to get the 0 term, we will count backward. 4 minus 2 is equal to 2. So the general terms of the sequence is equal to 2n plus 2. Question B. If a member of the family has 30 carbon atoms, how many hydrogen atoms does it have? So, Tn is equal to 2n plus 2. So, 2 times 30 plus 2 is equal to 62. So the member of the family has 62 hydrogen atoms. Question C. If a member of the family has 52 hydrogen atoms and A plus B carbon atoms, given that A is an even number and B is an odd number, find the possible value of A and of B. So, to solve the question, see, we know that Tn is equal to 2n plus 2. 52 is equal to 2n plus 2. So to get the 2n is equal to 52 minus 2. 50 is equal to 2n. 2n means 2 times n. So n is equal to 50 divided by 2 is equal to 25. And don't forget, A is an even number while B is the odd number. So, a possible value of A and B is 12 and 13. A is equal to 12. B is equal to 13. The members in the family of chemical compounds are made up of carbon atoms and hydrogen atoms. First, the number of carbon atoms and hydrogen atoms of the first 4 members in the family group are given in the table. Copy and complete the table. The first column is the member number 1, 2, 3, 4, 5, 6. So the general term of this sequence is equal to n. The next column, number of carbon atoms 2, 3, 4, 5, 6, 7. So now here the first term is 2. The second term is 3. The third term is 4. The fourth term is 5. So the general terms of the sequence is equal to n plus 1. The next column, number of hydrogen atoms 4, 6, 8, 10, 12, 14. So now, how to get the general terms of the sequence? The common difference is 2. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. So now here, the common difference is equal to 2n. The first term is 4. How to get the 0 term? We will count backward. 4 minus 2 is equal to 2. So the 0 term is equal to 2. So the general terms of this sequence is 2n plus 2. The second question is, if the eighth member of the family has 55 carbon atoms, here's the carbon atoms is 55. Find the value of H. So to get the number of carbon atom is n plus 1. So to get the member number is n minus 1 is equal to 54. Hence, find the number of hydrogen atoms the member has. To get the number of hydrogen atoms is 2n plus 2. So 2 times 54 plus 2 is equal to 110. If the K member of the family has 120 hydrogen atoms, find the value of K. Pn is equal to 2n plus 2. 120 is equal to 2n plus 2. (120 minus 2 is equal to 2n. Over here, 198 is equal to 2n. 2n means 2 times n. So n is equal to 198 divided by 2 is equal to 59. K is equal to 59. Next, hence, find the number of carbon atoms the member has. To get the number of carbon atoms is n plus 1. 59 plus 1 is equal to 60. So the answer of the third question is 59 and 60. The fourth question, a member of the family has 72 hydrogen atoms and 3 open bracket A plus B close bracket carbon atoms. Given that A is greater than or equal to 0 and A is less than B, find the possible value of A and of B. So over here, the general terms of the number of carbon atoms is equal to n plus 1, while for the hydrogen atoms is 2n plus 2. There are 72 hydrogen atoms. So 2n plus 2 is equal to 72 hydrogen atoms. 2n is equal to 72 minus 2 is equal to 70. 2n means 2 times n, so n is equal to 35. Then, to get the number of carbon atoms is n plus 1. So the carbon atom is n plus 1 is equal to 36. 3 open bracket A plus B carbon atoms. 3 open bracket A plus B close bracket is equal to 36. So A plus B is equal to 36 divided by 3 is equal to 12. A plus B is equal to 12. And remember, A is greater than or equal to 0 and A is less than B. So the possible value of A and of B is A is equal to 5 and B is equal to 7. 5 plus 7 is equal to 12. Question A. Consider the sequence 1, 3, 6, 10, 15, and so on. First, write down the next 4 terms of the sequence. 1, 2, 3, plus 2. 3 to 6 plus 3. 6 to 10 plus 4. 10 to 15 plus 5. 15 plus 6 is equal to 21. 21 plus 7 is equal to 28. 28 plus 8 is equal to 36. 36 plus 9 is equal to 45. Second, hence, write down the next 4 terms of the sequence 0, 1, 4, 10, 20, 35, and so on. 0 to 1 plus 1. 1 to 4 plus 3. 4 to 10 plus 6. 10 to 20 plus 10. 20 to 35 plus 15. So now over here, look at the pattern. 1 to 3 plus 2. 3 to 6 plus 3. 6 to 10 plus 4. 10 to 15 plus 5. 15 plus 6 is 21. 21 plus 7 is 28. 28 plus 8 is 36. 36 plus 9 is 45. So after that, 35 plus 21 is equal to 56. 56 plus 28 is equal to 84. 84 plus 36 is equal to 120. 120 plus 45 is equal to 165. Question D. Consider the following number pattern. 1 cubed minus 1 is equal to 0 is equal to 6 times 0. 2 cubed minus 2 is equal to 6 is equal to 6 times 1. 3 cubed minus 3 is equal to 24 is equal to 6 times 4. 4 cubed minus 4 is equal to 60 is equal to 6 times 10, and so on. So the general term of this sequence is m cubed minus m is equal to p is equal to k times 84. Use the result from part A to answer the following questions. First, write down the 9th and 10th lines in the pattern. So, the 9th term is equal to m cubed minus m is equal to p is equal to k times 84. So 9 cubed minus 9 is equal to 720. How to get 720? 6 times 84 is equal to 720. To get the 10th term is 10 cubed minus 10 is equal to 990 is equal to 6 times 84. Question B. Find the value of m, p, and k. So, over here, we know that the general term of the sequence is equal to m cubed minus m is equal to p is equal to k times 84. Notice that the number of terms follow the number of terms for the sequence 0, 1, 4, 10, 20, 35, 56, 84, 120, 165. Since the 8th term is 84, then 8 cubed minus 8 is equal to 504 is equal to 6 times 84. So K is equal to 6. P is equal to 6 times 84, 504, and M is equal to 8. Or another way is, we know that K is equal to 6. So 6 times 84 is equal to 504. And then you may use guess and check. M cubed minus M is equal to 504. So 8 cubed minus 8 is equal to 504.
That's all from me. Thank you for watching. Don't forget to like and subscribe.